In this video, we're going to plot our ADC result so we can have a look at the runtime performance of our ADC. In the next use case, this will become more useful as we explore the spike detection feature of the analog to digital converter with computation. So from the API reference, we have the instructions of the configuration and the required code snippets in order to build up this use case. Once we have done this, we will be plotting the ADC result at the top, a sample count in the middle, and toggling a debug I/O at the bottom. Let's get into it. Conversions are triggered by a timer overflow callback, where the data streamer variables ADC result and ADC sample count are updated. And then after each conversion, the LED is toggled and send frame is set to true so that the frame is sent to the data visualizer. So we'll add 3 components to our project: ADCC, data streamer, and timer. So to the builder, we're going to remove UART. We have ADCC. We can add a data streamer. And we'll pick a timer. We basically have the default configuration of the ADC, and then the data streamer and timer configuration are the 100 millisecond timer and the data streamer use case, which sends frames at a period set by the timer, which happen to be 100 milliseconds. So for the data streamer, we have 2 variables, sample count and ADC result. So first of all, what we need to do is select the UART dependency. And from our kit window and our device schematics, we see that any UART can be mapped to the specific pins that we need. So you see that this warning goes away about selecting a dependency. And in pin grid view, it was the UART and RB7, which is TX. So now we can add the 2 variables, sample count, which was a uint8, and ADC result, which is a uint16. So there's a reference to the timer 0 use case, 100 millisecond timer, and here clock source, low frequency internal oscillator, requested timeout 0.1 seconds, and enabling a timer interrupt. So low frequency internal oscillator. Now we just need a prescaler that gives us a 0.1 or more here. And a prescale of 16 gives us that. So we have a 100 millisecond timer and we want an interrupt. LED as output and name it LED. And if we go back to our ADC, select LED as output and name it LED. So our LED pin is RC1, C1, which we'll name under pins. So if we'd like to check the frequency of our ADC samples, we can do this by using a debug GPIO. So we can see that our debug IO is on RC0. So we select that pin, and then in the pins we name this debug IO. And the important part here is the analog input. So we are using a potentiometer on microbus slot 1, RC3, which is analog pin input 3. You can see that that is selected, and so it looks like we have the configuration that is needed. Generate. Okay, so let's look in main. So first of all, this will be our DS file for the data streamer. And because we have set up those variables, that is what we have. So here we're going to use a timer interface, and we're going to have a send frame set to false initially. In main, we'll just replace the whole main that we had from before. Now, because of the way we create the timer pointer to point at the address of a timer interface, we can easily change the timer by just replacing what the timer pointer points at in terms of the hardware timer interface. Now we register a timer callback, which we can copy this code here. You can see that similar to before, we're discharging our sample capacitor and then setting the conversion result to the ADC result, and then increasing our sample count. We have just forgotten to debug IO toggle. Opening the data visualizer, we're not going to use the terminal, but under the COM port 96 is what we had. We can select new variable streamer. Here it gives us the root of our project, and we go to generated files, data streamer, and select this file. Next, generally we want a new access per data type. Finish, and you can see that we're now plotting. So the one thing missing, which we wanted, was a debug GPIO, so we can add a new plot. Now notice the top value is our sample count. So let's remove this and rather add a new plot below, or use this plot we've just added. And here we want our sample count. And then the top value is the ADC result, and here we can put a debug IO. Show that we start streaming that. Okay, so now as expected, we have our debug IO and the sample count, and can now adjust our ADC value. And so we get the results expected.